Hello everyone. This is Bincy Joseph from the Department of ISC, AJIT, Mangaluru. In this session, we will discuss the last topic in fourth module, that is DHCP and NAT, that is Dynamic Host Configuration Protocol and the Network Address Resolution Protocol. Okay. We'll start with the DHCP first. This dynamic host configuration protocol, it is an auxiliary protocol in network layer, which helps to get the network layer address for a host. Okay, this DHCP is used to dynamically assign addresses in an organization. You can assign the address manually, or you can go for, but it is difficult, so you go for assigning the addresses dynamically, automatically. Okay. Now this dynamic host configuration protocol is an application layer program using the client server paradigm that actually helps TCP/IP at the network layer. First, we will look into the DHCP message format, and then we'll discuss the DHCP operation. Okay. This DHCP is a client server protocol, that is a client sends a request message and the server will return a response message. This figure shows the general format of the DHCP message. All the explanations is given here itself, the field explanations. See, it is a 32-bit packet format. First, you have the opcode. If the opcode is 1, means it is a request message, and if it is 2, means it is the response message. Okay. Next, you have the H type, that is the hardware type, Ethernet, which you are using, that is the LAN or WAN, whatever it is. Okay. The type, it describes the type. Then the length of the hardware address, this one, H length is the length of the hardware address, and H count is nothing but the maximum number of hops the packet can travel, the distance till distance, or the number of nodes it can travel. Okay. And then you have a transaction ID, that is nothing but a random number which is used for one transaction. Okay, this transaction ID which is generated by this client will be repeated by the server as well. Next, you have the time elapsed, nothing but the number of seconds since the client started to boot. Okay. Next, you have flags. In this flags, if the first bit here is 0, means it is a unicast address. Unicast means 1-to-1, providing the 1-to-1 communication. But if it is 1, means the bit is 1, then it represents the multicast, that is 1 to many, that is a node is sending to many nodes. Okay. Next, the client IP address, it is set to 0 if the client does not know it, and your IP address, the client that is the client IP address sent by the server. Initially all these will be blank, okay, when you send the request. Next is the server IP address, that is it is a broadcast IP address if client does not know it. Then you have a gateway IP address, which is the address of the default router as seen by the internet. Okay. Next, you have a server name. server name, that is, it is a 64-byte domain name of the server, and boot file name, which provides a 128-byte file name holding extra information, and you have this options field. This is a 64-byte option field, and it serves two purposes. One is it carries additional information, or the second purpose is it carries some specific vendor information. Next is the DHCP operation. Okay. Initially, the joining host, we say whichever host wants to connect to the internet, that is called the joining host. Okay. This joining host creates a DHCP discover. This DHCP discover message, which okay, this DHCP message, okay, which is sent to the servers. In this DHCP discover message, only this transaction ID will be set. That is, it will generate one random number. That is the transaction ID. Here it is 1001. Okay. This message is that this lease time, client address, your address, server address, all these are blank. Once and then now once if it has a transaction ID, what it will do, this message is then encapsulated in UDP, in a UDP, that is a user datagram, with the source port set to 68 and the destination port set to 67. That is this port number it will set, and the destination port number, that is 67, to which okay. And then after it is encapsulated in the user datagram, this together is encapsulated into the IP datagram with this source address, that is 0.0.0 0.0.0.0, and the destination address, that is 255.255.255.255. Here this source address is set to this because this represents that it is the address of that particular client. Okay, that is, it refers to this host, that particular host. And this 255 is nothing but it is the broadcast address. Why this is set to this destination address is set to this is because joining host doesn't know this host, particular host, this is joining host. Okay, this doesn't know its own address as well as the destination server address. That's why it is setting it to this, and this source address and destination servers like this. Okay. Next is the DHCP server here. This is server. This server responds with the DHCP offer message here to the client. Okay. In this message, the your address, that is here 181.14.16.182. This your address will define the address for this joining host, this one. Okay, and the server address will have the address of the server, this 170 16.170. see here the server address, this is added to the server address in the pack message. Okay, it also includes the lease time, that is 3600. This is the lease time I told you, that is until when the host can keep the IP address. This is the time until when the host can keep the IP address. Okay, this message is now encapsulated in user datagram with the same port number, but it is in the reverse order. Now the source port is this one, right, server, that is 67, and the destination port is the client, that is 68. Okay, and then this user datagram in turn is encapsulated in a datagram with the server address as the source IP address. This one, source IP address. That is source address is now this one. This is the server address, and the destination address is again set to the broadcast address because to allow other DHCP servers to receive the offer and give better offer if they can. Okay, for that you are setting this destination address to this broadcast address. Okay. Now the joining host receives more than one offers. Not only this offers, it might receive more than that also, other offers also. And it will select the best one out of it and sends a DHCP request. This assume that it has selected this same server now. This will now the client will send this DHCP request message to the server which it has selected. As we are assuming that this itself is selected. Okay. All the known field values are set. That is all these field values. Transaction ID the same 1001, the random number initially which you have generated. Next the lease time, it is set. Then the client address. Now you got the client address from where? The server, isn't it? Your address. This is the client address now. Okay. And then you have the server address, that is this one. Server address is this one. Okay. Now the message is encapsulated in the user datagram, and in turn it is encapsulated in the IP datagram here. In the user datagram, now the source port is 68 and destination port is 67. And in the IP datagram, source address is now this client address itself. The client address which was assigned by the server, that itself is the source address, and the destination address is again how much broadcast address. Why is it a broadcast address again? Because this particular message, that is a DHCP request, it will be sent to all, that is just to let other servers know that their offer was not accepted. That's why it will send the message to all other servers. Okay. Next, finally, this selected server will respond with DHCP ACK, that is acknowledgement message to the client. Okay, if IP offered is valid, that is internet protocol offered is valid. If not, it will reply with one more, that is DHCP negative acknowledgement. If it cannot provide the service, then it will reply with DHCP and ACK. Okay. Again, this is also a broadcast address here. Why? Because to let others know that the request is accepted or rejected. If it is rejected, then even the other servers can send the acknowledgements, isn't it? That's why. Okay. In this DHCP acknowledgement message, the server defines the path name. Along with this, the server will define one path name of a file in which the client can find the complete information such as the address of the DNS server and all that. Then the client can use the FTP protocol, that is a file transfer protocol, to obtain the rest of the needed information. This is about the DHCP operation. Next, we'll see the transition state. This transition state is the machine state diagram for the client. Okay, that is for the joining host. It shows the joining host state machine. Okay. Now, initially it will be in this init state, that is the start join. It starts from here. See, there is a arrow mark. I told you when you have this arrow mark, it means that it is the start of a state. Okay, this is where it begins. Okay, initially it will be in the initial state. Next, when it receives a DHCP discover message, it moves to the selecting state. Okay, it will select the best server out of it, and then it will select the offer, and then it will move to the DHCP requesting state. And then when it receives a DHCP acknowledgement, it will move to the bound state. In this state, it can send or receive the messages. Now from the bound state, if you have a lease time, right, in the packet message, that is in the message, DHCP message, you have a lease time. If that particular lease time is expired by 50%, then this DHCP will send a request again, DHCP request for renewing the time. Okay, and then it will move to, once if it gets the DHCP acknowledgement, it will move to the bound state again. Okay, else if the lease time has expired by 75%, then it will it will move to this rebinding state here. Okay, from the rebinding state, it can send the DHCP request and move to the DHCP acknowledgement here. Else, if this particular lease time has expired, then it will move to the initial state. That is, again the DHCP has to send the DHCP discover message to the servers. Okay, here from the bound, it can also move to the DHCP initial state, that is when the lease is cancelled, that server is not providing the service anymore, then it will move to the initial state by sending the DHCP release message here. Okay, next we will see to the next protocol, that is the network address resolution protocol. This NAT is used to relieve the shortage of addresses to some extent. Okay, the network address translation is a technology that can provide mapping between the private and the universal addresses, and it also supports the virtual private networks, VPNs. Okay, here in the diagram, it shows the implementation of this network address resolution protocol implementation, how it is implemented. This private network uses the private addresses. See to this diagram now. Here, this is the NAT router which connects to the rest of the internet. Okay, and this is the private address. Okay, private network here, and which uses the private addresses. Okay, you have n number of hosts here with the private addresses 172.18.3.1 3.2 3.3 and up to 20. Okay, now this particular router is the one which connects to the other internet, isn't it? Now this router here, NAT router, will have two addresses. That is, one is this private address, and one more is this global address. Okay, now for the outside world, it can see only the NAT router with the global address, but here it will have one more address, that is its private address. Okay, this is how it is implemented. Now, how the address is address translation, how the address is translated. Okay, Here what happens is, see, you have a host here with the 172.18.3.1. Okay, this host will send the packet with the source address as this one, 3.1. When it reaches this router, that is a NAT router, this router will replace this particular source address, that this is a private address, right? This with the another address, that is a 200.24.5.8. This address, the same address of this particular, this is the global address of this particular NAT router here, isn't it? The 200.24.5.8. This is the global address I told you for this NAT router. With that address, it will replace this particular source address. Okay, and then it will send to the internet. When it gets back, when the node in the internet, what it will do, it will send the destination address as this one here, but actually the packet is to be sent to this particular host, isn't it? So with this destination address, the packet will reach this particular router, and then the router will forward that particular packet by changing the destination address to this particular address, and the packet reaches this particular host here. Okay, this is how address translation is done. Here is an example for one IP address, using one IP address translation. From this diagram, you can clearly know how it works. See here, you have a address translation table. Okay. Now, this is one private network. Okay. Now, this private network wants to send data. When it wants to send data, this is the source address 3.1, the host address, distance address, and the destination is 25.8.2.10. Okay. Now, and you have the data here. This packet is sent to the router. When it is sent to the router, it will have one entry in the translation table. It will it will be entered in the translation table. That is, this is the source, and the destination is this one, this destination, that is a universal. Here, this translation table has two columns. One is private and one more is universal. This is the source address, and this is the private address, and this is the destination universal address. Here, if the router, what happens, this particular source address will be replaced by this particular router's global address, that is 200.24.5.8. Understood? The router's global address it will be replaced by this one. Okay, and then the data is sent to the network. Now, from the network, how the data packet will be received, that is the source address, that is the destination node here will send the packet, isn't it? Reverse response packet now, or it will send to the client sender now. In that case, the destination is the sender now, so its address is put in this source address, that is 25.8.2.10, and the destination is 200 dot this one 8.5. What is this? This is actually the global address of this particular router, isn't it? Same router is here. See, the global address of this particular router. Now, what this router will do, it will refer to the translation table, and it will check what is the source address now, 25.8.2.10, right? See here, this is the universal source address. Then what is the destination in the private network? You have to check. That is the reverse one, private address. You check here. That way, that is this router will find the private address, that is 172.18.3.1, and it will send the concerned packet, this packet, to that particular private network by changing the source address to, instead of this, instead of this one, that is the destination address will be changed here. While receiving, the destination address will be changed. While sending, the source address has to be changed, isn't it? Here, while receiving, the destination address will be changed by the router. Okay. Next, we will look on to using a pool of IP address. Why we use a pool of IP address? See, using only one global address by the network address translation router, it will allow only one private network, that is a host, to access a given external host. To remove this restriction, this network address translation can use a pool of global addresses. See here, using one IP here, one IP, it can connect to only one private network. If you use more number of IPs, it can connect to more number of private networks, and many number of hosts from different private networks can send the packets to the universal internet global address. Okay. Next, using both IP addresses and port address. Why we want to use both IP addresses and port addresses? See, for example, you have a message to be sent to some destination from the private network, and see, the source, two host wants to send the address to the same destination. Okay, in that case, what happens is, one host is 172.18.3.1 and one more host, say 3.2, also wants to send the packet to the same destination, that is 25.8.2.10. Okay, in that case, what happens is, here in this routing table, the entries will be 172.18.3.1 and the universal address for that is 25.8.2.10, and for the next host, that is 172.18.3.2, the universal address will be the same, that is 25.8.2.10. Okay. Now, when you receive the data packet, the router has to check this translation table to know which is the destination address, isn't it? But here you will have two addresses with the two destinations. So the router will get confused to which it has to send. To this overcome this confusion, we use more than one columns in the router table, that is a translation table. These are the fields, that is a private address followed by the private port, external address. More number of fields are used here, external port and the transport protocol. Five fields we are going to use. Instead of just one IP address, we are going to use more number of fields, so that there is no conflict while sending or receiving the data from or to the private networks. Hope you are clear with these topics. This ends the fourth module in DC. Thank you guys for listening this session.